All right, this is Algebra 1B, Part 1. Yeah, Part 1. Unit 3, Lesson 2. We're going to look at algebraic expressions and some vocabulary and how to work with algebraic expressions. Okay. First thing we have is something called an equation. It's where you have an expression equaling another expression. So an equation, sometimes called a algebraic sentence, has to have an equal sign, right? Equal sign. Example, 2x equals 18. Okay? 2x is an algebraic expression, 18 is an algebraic expression. They're equivalent, they're an equation. Equations are made up of algebraic expressions. And expressions are made up of the following parts. They're made up of terms, constants, and coefficients. Okay, so consider the algebraic expression 5x minus 8. This algebraic expression is made up of two terms, 5x and 8. You'll notice that terms are things that are added or subtracted. Okay? The 8 has an x in it, or has no x in it. The 5x has an x in it. Therefore, the 8 is a constant, which is the opposite of a variable. A constant is something that does not change in value. And the 5x is a variable expression, and the 5 is called the coefficient. So a coefficient is a number multiplied by a variable. So coefficient on 5x is 5. It has two terms, 5x and 8 is a constant, and 5x is a variable term. Okay? Now we can use these, or we can identify various parts of the equations here. We're not going to actually solve the equations, but we can write expressions to represent word problems. Consider, for example, okay, Ali has already stacked 18 bricks. Ali can stack 5 bricks per minute. Okay, I can write an expression, an algebraic expression, that represents how many bricks Ali has stacked. Okay, I can write the expression 18 plus 5b. In this particular expression, 18 represents the bricks already stacked. Five B represents the bricks stacked per minute, 5 bricks per minute. And the real hint in this case that 5 gets multiplied by something is the word per. Per means for each. So in 0 minutes, she would have stacked 0 bricks. In 1 minute, she would have stacked 5 bricks. In 2 minutes, she would have stacked 10 bricks. In 3 minutes, 15 bricks, and so on and so forth. So let me make a table here to represent what we've got here. Time, 0. Bricks. In the original case, she would have stacked 0 bricks, but she's already stacked 18 bricks, so 18 is her start value. At 1 minute, she will have stacked another 5 bricks, so we're going to add 5. 18 plus 5 is 23. At 2 minutes, she would have stacked another 5 bricks, so 23 plus 5 is 28. At 3 minutes, she would have stacked another 5 bricks. So that's 33. And so on and so forth. You can see how she's stacking 5 bricks for every minute that we add to the time. Right? 18, 23, 28, 33, and so on. We can continue this pattern. So the 5b, we multiply the 5 times the, and actually it should have been m, because it should have been minutes. But b represents the number of minutes. And 5 represents the bricks per minute. All right. Okay, just one more example here. Let's see here if I can come up with another example that's like this here. Okay, Mitch spent $4 on soda. It costs $2 per hamburger. I can write the expression 4 plus 2h. 4 represents the cost of the soda. Every hamburger costs $2, so I'm going to multiply the number of hamburgers by 2. So the price per hamburger. And h represents the number of hamburgers. And we can make a table. Hamburgers. If we buy 0 hamburgers, the cost of his meal is $4 because he bought a soda for $4. Expensive soda. If he bought 1 hamburger, he just added $2 to his meal. If he buys 2 hamburgers, he just added another $2 to his meal for a total of $4 added to his meal. If he buys 3 hamburgers, he just added another $2 to his meal for a total of $12 for his meal. And he's added a total of $6. $6 for 3 hamburgers, but add the $4 original cost. So again, that per word is a key. It tells you this is going to be a number multiplied by a variable. 2 is the coefficient. Hamburgers is the variable. All right. Hopefully that makes sense. One more example here, and that is working with parentheses, or one more concept. Parentheses are working from the inside out. So let's say we have an expression, 7 times 2 squared minus 3 times 5 minus 4. Okay, and actually we want square brackets. We can use nested parentheses. We do when we use computer software, because computer software doesn't usually use brackets. But the tradition is that we use brackets when we've already used parentheses. So bracket matches bracket. And if you go up another level, we'd use braces. Okay, but we work from the inside out when simplifying. Okay, so in this particular case, inside out would be 5 minus 4. Okay, so we 5 minus 4 first, and we get 1. Write the rest of the expression. Okay, now we continue. We're working with something called PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponent, multiply, divide, add, subtract. Exponents come next. 2 squared is 2 times 2, or 4. Multiply comes before subtract. 3 times 1 is 3. Four minus 3 is 1. 7 times 1 is 7. You'll notice the upside down triangle shape we got going on right here. Okay, that is indicative of a simplification problem. There is one simplifying problem that tends to mess people up, and I want to present that here. If I have negative 2 and I square it, that means negative 2 times 2. In opposition to if I have negative 2 in parentheses squared, that means negative 2 times negative 2. Negative 2 times 2 is negative 4. Negative 2 times negative 2 is positive 4. So just be aware that when you're dealing with exponents, exponents work on what they touch. The negative 2, or the 2 exponent only touches the 2, not the negative sign. In this case, the 2 exponent touches the parentheses, and so it gets the whole thing. Okay, that's very important to catch. Hope that helps.